Alright, hello. Welcome to this short tutorial series. So this will show you how to set up pros, and later on we'll move on to adding lemlib, which is a library which allows you to do many things including odometry, and we'll also show you some tutorials to set up some hardware for odometry tracking. So first of all, you have to download Visual Studio Code. So you can just go to Google, type in Visual Studio Code. This works for both Mac and Windows. You just need to click download and it'll pop up here. Wait for it to download. Alright, now that it's done, you can just follow the installer. And this will install it onto your computer. Alright, now that's done, we can launch Visual Studio Code and we'll get put here. So before we do anything, we still need to install some extensions, which adds extra functionality to base Visual Studio Code, and it will allow us to connect with our V5 robot brain. So the first extension we need is called Clang GD, which is for C++. You'll have an install button right here, but I have it installed already. But you'll have an install button, you have to click it, and it will install. The next one we need is the VEX Robotics plugin, and you can install it here. This is useful for like troubleshooting because you could see which devices are connected. And lastly, we need to install pros, which is this one. You have to click install, and then you'll see this pop up in the bottom right. You need to install pros client and toolchain, and then this is very important. You have to click this or else it won't work, and pros client might take a while to install. Alright, so if you have this message in the bottom right, that means everything's successfully installed and you can move on to the next video. Alright, this video will show you how to create a project in Pros. So in the last video, we installed Pros and all of the extensions we needed in VS Code, and now we're going to create the actual project that we need. So first, you need to find a place where you want to put your project. I'll put it here. It's a random folder on my documents. So I'll create a new folder and you can name this anything you want. I'll just name it VEX project. Alright, and now that we have that, we can go back to VS Code. If you see on the side, on the left here, we have a button that says pros. It has this icon. You just need to click on it and then go down to conductor and click create project. And now we have to navigate to our folder that we created just now, right there, and then click select folder. This will come up. It'll prompt you to put a name for your project. I'll just do my project there, and then you want to select V5 if you're doing VEX V5. So we'll select latest, which is 4.2.1, and then this should pop up in the bottom right, and it might take a bit. Alright, so now that we've created our project, I want to configure how it shows up on the brain. So you can go click explore here on this left, and then navigate down to project.pros. Click on it, and then you can set your project name, description, program slot, program icon. So project name is like when you click it on the brain, what will it show up as? I'll just do like main drive, and then a brief description of your project will also be shown when you click on it. So this is a drive program, and then program slot is the slot that will be uploaded into. So you could put 1, 2, 3, 4, 8. And then program icon, you can select whatever. It'll change here. And then if you see this white circle here, you need to click Control S or Command S or File and then Save. So, and the circle will disappear and your project file will be saved. So this part of the tutorial will tell you how you upload your program to your brain, which will be useful later when we test different codes that we write. Okay. You want to go to the pros icon on the left, this button, click on it, and then your robot brain, it has USB port on the left of it, and you want to plug one end into your computer and one end into the brain. So yep. Then if we go back to Visual Studio, we can see that in the bottom right, it says our brain's connected, which is good. Here you can set your team number, like here, 4139B. You can set your robot name. You can set and you can update VEX OS. So like we set up the project earlier, we have the right program slot. All you have to do is click build and upload, and basically a language that the brain can understand, and then the actual uploading is sending it to the brain. So you could see here we have project uploaded successfully, and that's how you upload a project. Alright, in this video, we'll be showing you how to declare different objects for the different devices that you'll use in VEX. So this tutorial will go over motor group, singular motor, pneumatic, and some commonly used sensors. So these with the 2 backslashes are comments. So if you do 2 backslashes, it'll turn green, and then these comments just let you know what your code does, so it makes it easier for you to read and understand your code. So that's why I put comments for these. So what we're gonna do first is we're gonna find the ports for everything, and then we'll set them up as objects. So our motor groups are gonna be our left and our right side for our drive base, because we want all of the motors to work together in a group. So to find which ones are on the left and which ones are on the right, I'll switch to my camera. You could go into the devices tab here, and then port free. For example, this would be on the left, on the right, because it's moving the right side of our drive base. So you can use this arrow here to move it forward, and this arrow to stop it, and this arrow to move it backwards. So we know that the way I have it set up is 3, 4, and 5 are the right motors, 8, 9, and 10 are our left motors. I'm gonna show you how to set that up in VS Code. So just a reminder, left, 3, 4, 5, right, 8, 9, 10. Okay, so set up a motor group, we have to use our pros library that we installed earlier. So pros, : motor group. Now we have our motor group, we can name it, so left motors, and then we'll use brackets. But since we have many ports, we need to make a list, so we use curly brackets to make a list, and then I'll put 3, 4, and 5 in our list. So that's our left motors done. And now if I need to add my right motors, I'll do 8, 9, and 10. There we go. So that's our motor group done. So next, let's go find the ports for our singular motors. So this is useful for like if you have an intake which you just need to move by yourself, or some other mechanism which the motor needs to move independently using a button. So we can do the same thing here. Our devices, I see that our intake motor, which is this, the wheel is attached just for example, it's in port 6. So this is a 5.5 watt motor, but we control it exactly the same as how we control the other motor. Alright, so now that we know that our motor is in port 6, I'll add a comment port 6, and for our pneumatic, I'll switch back. Since the pneumatics are using a free wire port, we want to select this bit, and then we can see all of our ports. We can see that our solenoid's plugged into port B right now. So if we change port B to digital out, you can hear it click. That means the solenoid's working. Go back. So it's port B. And then same for the sensors. I'll just read off the brain. Rotation, port 2. Inertial is in port 20. Okay, so now if we're ever like confused on how to use a command in pros, we can go to here, which is like a documentation website. Search up pros 4 and it will bring you to this website. So everything that we need is here. So let's say we wanted to see how to use motors. We could go here, motors, and this is how we would use our motors. And they also have examples. Okay, so for our motor group, this is for our drive base. So you could have your left motors and right motors together. So this would work for any amount of motors, 8, 6, 4, 2. So let's do the right side drive first. So I'll go pros and then : motor group, and then right motors. And then this is where we're going to put our port. But since we have more than one port, we have to use curly brackets to make a list. And since we know that our right motors are in 8, 7, 8, 9, we can just go 7, 8, 9. And then I want to do the same for our left motors, which is 3, 4, 5. Okay, so now we can move on to our singular motors. This is useful for like, you have an intake motor which just needs to spin by itself. So same deal, pros, motors, and then I'll just call it intake motor. And then since that this is only one port, we don't need the curly brackets for this. And I know that it's in port 6. Pneumatics here, same, pros, and then we need to go to ADI, which is basically how you control the free wire ports, because they're different to the smart ports that your motors plug into. So pros, ADI, and then pneumatics, and I'll call it my solenoid. There. And then in our brackets, we're gonna put our port, which is B, and then the second argument is whether it starts extended or not. You can see here, it says, and it's a boolean, so true or false, and we'll just put false, because we don't want it to start extended. Next up, the sensors, pros. So we'll do our rotation first, which is just rotation, and then my rotation. And then we know that it's in port 2, so port 2, pros. We'll do the inertial, which is IMU. There, and then my IMU, and we know it's in port 20, so we'll just put 20. So if you have other sensors like color sensor or distance sensor, you could also put them in the same way. You could just go pros color, or pros vision, or pros distance, and you would declare it the same way. So now that we have all of our objects declared, we'll move on to programming them in the next video. If statements perform certain actions depending on the inputs. So let's say that we have our one input here, and we put it into our if statement. So an if statement usually only has one outcome, which would be, let's say it performs scenario 1. So for example, let's just say the input has to be more than 10. Is more than 10. So if our input is more than 10, it will perform scenario 1. But if it's not more than 10, it will do nothing. But in our controller logic, we don't want that to happen. We want it to move a motor when we're pressing it, and to stop moving a motor when we're not pressing it. For that, we can use if-else statements, which gives us two scenarios. We can have scenario 1 or scenario 2. So if our condition is not met, it will perform scenario 2, and if our condition is met, then it will perform scenario 1. So for this example, I'm just gonna put a random input of 13. So let's see what our if statement spits out when we put in 13. So is 13 more than 10? It is more than 10, meaning it will perform scenario 1. So that's the decision that our if statement made. But let's just say, for example, we want to change this input from 13 to, let's say, 5. So our input's now 5. Is 5 more than 10? No. So it will perform scenario 2. How we apply this to our controller is that we can say if our input can be, it doesn't have to be a number, it could be true or false. So we'll change this operator here. The standard operators in C++ are more than, less than, equal to, or not equal to. So these are the main operators that we have. All of these could be used for numbers, but for true or false, we would use equals, because there's only 2 states. For example, if our button, let's just say we have our Boolean variable called button, and that is set to true. we can ignore this because we're not using numbers anymore. Let's say that our boolean name button is set to true. So we want to change the operator to be an equals true. So if we're pressing the button, it will be true. If we're not pressing the button, it will be false. So if I'm pressing this, true. If I let go, false. So we could say input, our input's true. Is the input true? Yes, it is true, meaning it'll spin the motor forward, which would be scenario 1 in this case. Or we could use an else statement. We can use an if-else statement. So let's say I'm not pressing the button now, so I'm changing it to false. So now, is the input true? No, so it'll do this. So it'll do scenario 2, which is to stop the motor. So that's the basic logic behind what we're about to program. So if we go back into our main.cpp file, we could scroll down to where our controls start, which is here, OP control. All of this is to set a basic drive. And as we've already declared our own motor groups, so I want to open our if statement by putting if, and then we have to put a bracket. Okay, now that we have our if statement, we want to add our condition, which is whether we're pressing the button or not. So that would be controller, so master, because that's what our controller is called, as it's defined already up here. Master dot get digital, and then I'll use R1 as our button, but you can use any button, the button that you want to initiate the action with. So between these curly brackets is what the action it's gonna run is gonna be. So I'll just put code that runs when press, and then like I said before, we want to put else, and then code that runs when not press. Okay, so we want our intake to move, so I'll do our intake motor dot move, and then 127. For pros, the 100% torque, 100% velocity would be 127, and negative 127 would be the same thing, but in the opposite direction. 0 would be not moving, and 64 would be like 50-50 speed torque. So that's us moving forward, and then intake motor dot move 0, because we want to stop it. Okay, so yeah, that should be our simple if statement, and let's go test if it works on the robot. Okay, so now we've uploaded the code. We have our motor plugged into port 6, and I'll demonstrate how it works. So we're running our program on this controller, and when I click R1, this button, when I click R1, the motor moves. And then when I stop clicking it, it stops moving. Alright, I've gone ahead and found the right orientation for all of our motors right now. So now we can continue back to programming drive motion. So you can see that here we have arcade drive already set up. So this is the logic behind it. The voltage is the direction minus turn, which is the left joystick minus the right joystick, and opposite for the right motors. So we can try upload this and see how it works. So now that we've uploaded the code, we can go into our programs here, and then select the code that we just wrote. It should run, and then our joysticks should be able to move the bot around. So it can turn forward, backwards with all 6 motors. So in this part of the video, we'll actually show you how to control the solenoids using your controller. So you can see here that my free wire ports are connected already, and I have all my tubing for my solenoid, and it's plugged into port B, and we've added the object for the solenoid already in the first bit. Just make sure it works. You can click on it, up, down, and we're gonna move on to the code. So for this solenoid, we're gonna want to make a toggle instead of a when pressed. So I'm just gonna make a boolean for whether it's extended or retracted. So I'll do like lag state. I'll set it to false first. There you go. And now we actually have to get the controller input. So if mass dot digital get digital new press. This will run when we get a new press, and we're going to use R2 in this case, digital R2. So this is checking when we get a new press, but we're actually going to nest another if statement inside called nested if statements. So if the flag state is false, which it starts out as false, then we'll extend it, do my solenoid dot extend, and we'll set flag state true. Else we'll do my solenoid dot retract, and we'll set flag state false. So this should allow us to toggle it on and off every time we click R2. So I'm gonna go ahead and save, and then I'll upload that to my robot. We'll see what the code does. Alright, so you can see what happens now when I try to run the program. Here, I'm gonna click R2, and you can see that our piston deploys. Alright, so in this part of the video, we're going to be programming our pneumatics. So we set up the object earlier. I just want to make sure it's working first. So you need to make sure everything's wired properly. So you can see I have my solenoid here, and it's wired to the brain in port B. I set up the object in the earlier video, and you can see that the regulator is regulating airflow into the solenoid, and the two wires are going out into my piston right here. So you should be able to go to the brain in devices and the free wire, and then you should be able to turn it on and off by clicking on the solenoid, which works in my case. So we're all good on the hardware part. So to program it, I'm gonna use a toggle switch, unlike our motor that we did earlier. So for our toggle, we're gonna use a Boolean variable. So I'll put bool, I'll just name it flag state because this toggles up and down my flag. I'll start as false. And then now that we have our Boolean declared, this will tell the program whether it's extended or retracted. So then I'm gonna use an if statement to detect a new button press. So master.get digital new press, because it's a toggle this time. We only want to get one press, and the button I'm going to use is R2 for this demonstration, but you can set it to whatever you like. And I'm going to nest an if statement inside. It's called a nested if statement because it's within another if statement. So once we get the button pressed, we want to see if we need to retract or extend it. So I'll go if flag state equals false, then I will extend it. So my solenoid dot extend, and then I'll set flag state to true. So we know that it's extended now. And then if it's true, I'll use this else to retract the solenoid. So my solenoid dot retract there, and then I'll set flag state to false. So this should be a good toggle logic, and build and upload, and we'll see what it does in the bot. So now the program's uploaded. I'm gonna try run my program, and we'll see what happens. There, you can see I'm gonna click R2 on my controller here, and the flag should go up. Now I can toggle my intake and my flag up and down. So that's the logic for the intake and pneumatics. So I hope this video helped you.